Never build a product.
Build a platform.
Let's talk about the 3 things you need to know before designing the architecture of your mobile robotics platform. Hi, I'm Sujata.
I'm Altaf.
And I'm Ian.
First of all, let's talk about making updates and improvements to your platform.
Yeah, so in industrial applications, mobile robots need to actually be in service for a long time. These products need to be in the market for maybe 5, 10 years. So you need to be able to update these systems with new sensors and new capabilities to be able to address the needs of the customer as they evolve over time. So you need a scalable architecture.
That's a lot to think about. So when you're putting your platform or product into the real world environment, it needs to be able to stay there for up to 10 years.
Yeah, exactly. So this is where, you're looking at different architectures on how you can scale this architecture, right? If you go with a centralized architecture where you have a high performance processor that's going to do everything, and you're going to have sensors that feed all of that data to that central brain, that makes it difficult to upgrade. If you need more performance as you add high resolution sensors or sensors that require more processing, you also have to update that high performance compute as well. With a distributed architecture, you can actually have more processing done at the edge in the sensor itself, so it's a lot easier to scale.
So the second thing that comes to mind is, how does a company drive long-term revenue? So being able to bring in new services or models to drive additional revenue in the future.
Yeah, I mean, it's clear that today robotics is a very fast-moving uh, industry. So, uh, not everything's going to be ready. There's going to be new sensors, new capabilities that are coming down the pipe, but you have to build and produce something sooner rather than later. So, by planning for that now, you can have a model that gets easily upgraded modules or distributed sensors or additional features that can be added on and sold at a later date based on the base model. The other capability is, of course, having scalability within that ecosystems where you have a base model of a robotic system, and then by picking the right processors and the right architectures, a lot of that is reusable depending, and you can pick whichever processor or subsystems are needed for that particular application. So it's really needs to be thought out from the beginning.
You might not have thought of some of the features and capabilities that are going to be available in the future.
You don't know what
So
you don't know.
exactly. So new sensors come out with new capabilities that you hadn't thought of. So if you have this distributed architecture, you can easily add that capability and generate new revenue services, right?
Because with the new capabilities, it gives you new ways of delivering different experiences that the customer will find value in paying for.
Right, exactly.
And then Altaf, you and Ian both already touched on this, but this is what I view as the third thing you need to know is, how do you drive your platform to be scalable today and in the future? And so maybe both of you could dive into a little bit more detail on what that means when you're thinking about the architecture you're implementing.
Right. I mean, typically in robotics, there's a subsystem or operating system, not really an operating system, but it's called ROS 2. And that's a publish and subscribe architecture, and it can involve more than one processor. So ideally, what you do is optimize those processors for what you need the product to do. And in the case of, say, this buggy reference design, B3RB, there's a main processor that does vision and path planning and the higher level thinking. But it's much, much more cost optimized to do all the real time stuff in a companion microcontroller. And what's nice about this is, because of the software architecture that we've enabled for you, you can swap that out with a similar part running the same software, but perhaps with different capabilities.
Yeah, and I think that scalability and modularity is key here. You can pick the right MCU that has different capabilities, different performance levels, and the same thing for the companion computer as well. So you can scale that depending on what type of capabilities and also what type of robot you're actually building as well. There's many different types of robots, and you really want to have an architecture that can scale to address these different form factors for the robots as well.
And we started this off by talking about don't build a product, build a platform, right? So don't build the minimal viable product that you need to get out the door immediately. Build a platform. And what are some of the things that can go wrong if you don't take this platform approach?
Well, one aspect is, we see it a lot where people just want to build something and get it working, and then what happens is they end up with much, much more expensive hardware than they really need to be successful in the market that they're shooting for. That's not to say there aren't very expensive robotics equipment, but there's certainly you need to keep an eye on how's it going to scale as your volume goes up, and how are you going to get more optimized, um, you know, subsystems, modules, motor drives, vision sensors, those sorts of things.
So sometimes doing proof of concepts and trying to take those to market can end up costing you more in the development. It might get you to market more quickly, but it costs you more in the long term.
Right. And you have to be prepared for it. That's all. Be prepared for that transition and think about it right from the beginning.
This was another conversation at the edge. What did you think? Leave us a comment and click on the link below to access all of our episodes related to mobile robotics. Thank you.